Hi guys, welcome to our online classroom. Today we'll be doing some physical sciences topic. Let me take you to my presentation. Okay, so now we'll be doing work, energy, and power. Okay, you can look at this guys. They're saying that why are we working so hard? Okay, grade 12 physical sciences. Now our focus today it will be on introduction, defining work, conservative and non-conservative forces. We'll also look at energy, types of energy, kinetics and potential energy, work energy theorem, mechanical energy, and power. Okay. Now, on the introduction, we use term work in our everyday conversation to mean many different things. Okay. We talk about going to work, doing some homework, working in class. So nowadays, some people they talk about workout, meaning that in a form of exercise, okay, and all that. Okay, in physics, but it's something different. In physics, we use the term work to describe the process of transferring, okay, transferring energy from object or system to another, or converting energy from one form to another. Okay, lifting objects or throwing them requires that you do work on them. So when you are busy lifting or throwing or rather kicking a ball and all that, you're doing some work on that object. Okay, let's define what is work. Work is defined as the product or the force parallel to the movement of an object and the displacement of the object. Okay, measuring SI unit of work is joule. The symbol for joule is J. Okay, network is done by a net force. Okay, in symbol, we mean that the formula is work done because they're saying that is a product of a force, and the displacement is a force multiplied by changing x. Okay, by changing x, it's a displacement, and F is a force. Okay, so we use this formula when F and X are parallel. Okay, in general, the general formula, okay, for work is equals to F cos theta multiplied by delta X, meaning that this is the component of force. Remember, you've got horizontal components and the vertical components. Okay, so these are just units to say that 1 joule is equivalent to 1 Newton meter, to say that force is measured in Newton and displacement is measured in meter. Okay, and then we also know that for Newton, it can be written as force is equal to ma, meaning that it's a mass multiplied by acceleration multiplied by m. Okay, so which means it will be 1 kg m squared. M multiplied by m is m squared per second squared. Yeah. So now let's look at the cases of work. Okay, we've got cases of work. Okay, which are the cases whereby work is done, and what are the cases whereby a work is not done? Okay, number one, you do a positive work. Positive work is done on an object to move it in direction of the force. Okay, so meaning that when your force and your displacement are in the same direction, you can look here, in the same direction, you do a positive work. Okay, so they're also saying that the positive work increases the kinetic energy of an object. Okay, we'll talk more about kinetic energy on the following slides. Okay, and then also a negative work is also done by an opposing force. Okay, by an opposing force, meaning that that's where a force and a displacement, they are not in the same direction. Okay, sort of angle here is 180 degrees. Okay, so here, because they're going in the first case, because they're going in the same direction, the angle there is 0. Okay, and negative work decreases the kinetic energy. Okay, the kinetic energy is the energy an object has due to motion. Okay, let's look at the last case. Okay, when force and the displacement are perpendicular, okay, no work is done. No work is done, meaning that your work here, it will be 0. Okay, so the force is going up and then the displacement is going to the right, meaning that the angle between the two is 90 degrees. Okay, and then let's proceed. Okay, let's look at the conservative forces. What is a conservative force? It's defined as a force for which the work done in moving an object between the 2 points is independent of the path length. Okay, it's independent. Note that it's independent of the path length. Examples: you've got gravitational force, elastic force in a spring, and Coulomb's forces. Okay, the non-conservative forces. This one, a work done is done in a moving object between 2 points, depends on the path length. So for this one, it depends on the path length. Okay, for example, you've got frictional forces, you've got air resistance, and then you've got a tension in a cable. Okay, let's proceed. Let's start. What is energy? You know, everybody knows energy is the ability to do work, or energy is the capacity to do work. In other words, it means that if there's no energy, right, work cannot be done. Okay, and then we also know that energy is a scalar quantity, meaning that what is a scalar quantity? It's a physical quantity which has got magnitude only. Okay, magnitude or size, and then therefore it does not have a direction. Now, measuring the unit of energy is joule. SI unit of energy is joule. It's J. Okay. We've got types of energy. You know, you've got thermal energy. This is the energy due to heat. And then you've got kinetic energy. This is the energy an object has due to motion, movement. You've got chemical energy due to chemical bondings. You've got sound energy due to sound. You've got potential energy, you know, and then you've got electric energy due to electric field. Here you've got nuclear, etc., etc. Now let's talk about kinetic energy. So kinetic energy of an object is the energy it possesses due to motion. Okay, the formula used to calculate the kinetic energy, okay, the formula used to calculate the kinetic energy is given by EK is equal to half mv squared, where m is the mass of an object and v is the velocity of the object. Okay, gravitational potential energy. Gravitational potential energy. Okay, this is the energy acquired by an object by virtue of its position in a gravitational field. Okay, the formula used to calculate the potential energy, so is EP is equals to mgh. Note here, guys, that this mg is weight. That's why we say in a position, we're saying that it's by virtue of its position, the position will be height in a gravitational field. So this mg is fg, so it will be fg multiplied by h, so which is weight. Fg is weight, whereby weight will be mgh. Okay, now let's proceed. Okay, conservation of energy. Okay, we know that the law of conservation of energy states that energy, okay, energy cannot be created or destroyed, but energy can only be transferred from one object to another, or transformed from one type of energy to another. You remember we talked about types of energy, so it can just move from, okay, sound energy, okay, to thermal energy or heat energy. It can just rotate in between. Okay, that way sometimes, you know, if you've got a car colliding together, so that way some way somehow you'll hear a sound, and then some way somehow you'll see some light or thermal, some heat and all that. So it's just the transformation of energy from one state to another. Okay, so now let's talk about work energy theorem. Okay, we talked about energy, we talked about work. Remember when we're talking about the cases of work. Okay, so now it means that work energy theorem is a combination of a work and energy. Okay, so expect some energy types here on energy. Okay, let's see. It said that the net work done, okay, the net work done on an object is equal to the change in object's kinetic energy. Okay, changing is delta, so it means that you have got changing kinetic energy is the final kinetic energy minus initial kinetic energy. And then we've already talked about what is kinetic energy, that when I said ek is equal to 1/2 mv squared. Okay, now let's proceed. Or work done on an object by a net force is equal to change in object's kinetic energy. Work energy theorem. Okay, work net, yeah, work net work done, work net is equal to change in kinetic energy, which is equal to kf, meaning this is the kinetic final kinetic energy minus initial kinetic energy. Okay, this is just saying that the total work done is the difference between the initial and the final kinetic energy state. Okay, guys, now let's look at the mechanical energy. What is the mechanical energy? Okay, state that the principle of conservation of mechanical energy state that the total, okay, the sum, okay, sum of gravitational potential energy, we talked about EP, okay, and the kinetic energy in an isolated system remains constant, meaning that now this is just the sum of EP plus EK, right? In an isolated, meaning that in a closed system. Okay, so in a closed system, there are no external forces acting on an object. Okay. The formula. So mechanical energy state that is the sum of change in kinetic energy plus change in potential energy. This is the work done. Okay. Now let's look at power. Okay. Many people, they talk about power in everyday life, and powerful and all that. Okay, now let's look. But here in science, in physics, we say power is the rate. Guys, when you see the word rate, just know that we're dividing by time. Okay, with the rate at which the work is done, the rate at which the work is done, or energy is transferred or converted. Okay, now power is just an indication of the rate at which how fast the work can be done, or how fast or slow the energy can be transferred from one form to another. Okay, power is also a scalar quantity, meaning that it has got only size or magnitude only, so there's no direction in power. It's not a vector quantity, it's a scalar quantity. So the unit of power is watt. So the symbol of watt is W. So power, we're continuing the formula to calculate power. Power, it can be change in work, change in time, because we said is the rate at which the work is done, because rate by dividing by time, or how fast or how slow the energy can be transferred. So here the work, it can be energy, it can be energy transferred. Okay, where P is just the power, here P is power. Okay, and then W is the work done, and then changing T is time. Average power, if you want to calculate the average power, you can use power average is equals to force multiplied by velocity. So whereby F is the force and V is the average velocity or speed. Okay, now let's look at the example. Example number 1. So this was a question paper last year, 2019 November exam. Okay, I took it from 2019 exam, final examination. Okay, here they're saying that an object of mass 1.8 kg slides down a rough curved track. Okay, note this word, a rough. So automatically it gives you idea, a hint that now, okay, there are some frictional forces or frictional force acting on an object. Okay, and passes a point A. This is a point A, which is 1.5 meter above the ground at a speed of 0.95 meter per second. An object reaches a point B, here is point B, at the bottom of the track at a speed of 4 meter per second. Okay, now I just want to give you some useful tools, you know, that in mechanical energy that you can also look at. Okay, let me go to the whiteboard. Okay, you've got suppose, guys, let's say you are given, let's say you're given a, okay, let me start with here. Let's say you've got objects. Oh, oops. Let's say you've got a scenario like this. You've got a scenario like this. Okay. Now, here you've got a certain height. Okay, from here to here, you've got a certain height h. Are we together? And also from here to here, you've got height h. Okay, and then assume that now here is ground, right? Here you're at the ground. Okay, so here you've got this guy here. You've got, for example, you've got this guy here. Let's assume this is the guy. Okay, now guys, here we can talk about EP. Here you can talk about EP. Here you can talk about EP here, because you've got a height, right? So here your EP is equals to maximum. So it's equals to max. So your EK your EK, the kinetic energy there, when it's still standing, is equals to 0, right? And then here at the bottom, when the guy is here, you've got your EK is equals to max, meaning your kinetic energy is maximum. Okay, it's maximum. Then meaning that your EP is equals to, you don't have height, so meaning your EP is 0. Okay, now guys, you'll agree with me that also in case of a pendulum, let's look at a pendulum which is swinging. Okay, in case of a pendulum which is sort of a swinging, you will have a case like this. Okay, so this ball is sort of moving to and fro, so you will have some certain height here. So when the ball is here at A and B and C, okay, so here you have got height, so you have got EP is equals to maximum, right? And then here you have got your EK, the kinetic energy, we can say is equals to 0. But here at the bottom, you have got your EK, because you don't have height, so your EK is maximum, so your EP will be 0, like that and that. So what now, when it is sort of a mid halfway, or also here, when the guy is sort of a mid halfway, your EP and your EK, they are equal, meaning that the potential energy and the kinetic energy are equal. Okay, now let's go back to our presentation. Now here we've got a certain height, okay, and the mass of an object. So here the thing that define the term conservative forces, we have talked about this. Work done is just independent of the path taken. Okay, and they're saying that name the conservative forces acting on an object. So here we had that this slope is rough, so you've got some frictional forces acting on an object. Okay, so here you can talk about conservative force acting on an object. You can talk about gravitational forces. So it's a mechanical energy conserved as objects slide from point A to B. Okay, no, yes or no? So it will be no, because now you've got a frictional forces, because of the frictional forces. Okay, calculate the gravitational potential energy. Okay, 1.4, calculate the gravitational potential energy. So here we said EP is equals to mgh. Here you have got your mass is 1,8, your g is 9,8, and then your height, you've got height which is 1,5. So you can calculate your EP, simple 3 marks. It will be in joules. Use the energy principles to calculate the work done by friction on an object as it is slides from point A to B. Here you can use mechanical energy. Okay, you can use mechanical energy. Work net is equals to work done by friction. So it will be friction, and then so we can say work net is equals to change in kinetic energy. Okay, so now let's you've got you make mechanical energy at point A is equal to mechanical energy at point B down there, and then you minus the work done by friction. So EP plus EK of object A up there, when it's still up, is equal to EP plus EK when it's down at B minus. So if this case there was no friction, you were gonna exclude WF, right? And then just solve what you are requested. So here EP is mgh plus half mv squared. Okay, note that now, note that when the object is at point B, you don't have a height, so your mgh, your h will be 0, so everything here will be 0. So mgh here you have calculated at 1.4 when the object was still up there. So the kinetic energy, you've got velocity when it's still up there, you just substitute, okay? And then half mv squared, you've got a speed of 4 when it is down there at B. Then you can calculate the work done by friction. Simple. This is simple stuff. Okay, guys. Now let's look at the possible exam question. Okay, now we have got a rescue helicopter stationary above a soldier. This is a helicopter, this is a soldier. Okay, the soldier of mass of 80 kg is lifted vertically upward through a height of 20 meters by a cable at a constant note, underline the word constant speed, okay, 4 meters per second. The tension in the cable is 990 Newton. So this tension sort of a applied force. Assume that there is no sideways motion, so there's no left or right during the lift. Air friction may not be ignored. It's not to be ignored. Okay, now you can state the work energy theorem. The work net is equal to change in kinetic energy. You can draw the free body diagram. Okay, you can draw the free body diagram. You can write the non-contact forces, gravitational force. This is just simple. You can use the work energy theorem to calculate the work done by a soldier by a friction after moving through a height. So here also you have to note that the work net. Okay, so you're going to add the work net of a gravitational force, the work net by an applied force, the work net by air resistance. Okay, now which is equals to change in kinetic energy. So if we talk about a constant speed, you have underlined here constant speed, so it means your right hand side will be equal to 0 because change in kinetic energy is 0 because your final velocity and your constant speed, it means that your final velocity and your initial velocity are equal. I know most people, they think that constant speed means that your speed is 0. No, that's wrong. Constant means it means that your object is moving at a constant speed. It's moving, but it's not changing the speed. Okay, so this is simple. You can write this question and put it on the comments. I will discuss. Simple. Okay. Now this is your quiz. You also have to write this one. So homework. You were given a trolley is at rest on a horizontal frictionless base. There's no friction. Here, the horizontal horizontal force of 80 Newton is applied on the trolley. Okay, then this trolley from here to here is 3 meters. So you can also answer this question. If you've got questions, you can put it on the comments. Okay, thank you guys. Another thing, don't forget to like, share, and subscribe to our channel. Thank you very much, guys.